I'm taking these notes today on April 3rd, 2017, and it is first period. Our essential question is, how do I find the area and perimeter of rectangles and circles? That's what we're going to do today. And so the first thing I want to define for you is area and perimeter, these two words. Scoot this up just a little bit and zoom in a bit as well. When we talk about area, what we're basically saying is how many squares fit inside. How many squares fit inside? And it's kind of easy when we talk about rectangles or squares, but it's a little bit harder when it comes to circles. But we're going to measure the circles in terms of squares as well. Just so you're aware, it's how many squares can fit inside whatever the shape is. One thing I put here in my notes from last year is I put units to the second power, like that, units squared. Whenever we measure area, if we're measuring in inches, it's inches squared. If we're measuring in feet, it's feet squared. If we're ever measuring in millimeters, it's millimeters squared. It's whatever the units are to the second power, because we have a length and we have a width. That's why we do it that way. Perimeter, on the other hand, is the distance around the object. This is not units squared. This is just units. Now for perimeter, I like to write down that what I do for perimeter is I add up all the sides. When we're finding a perimeter, we're adding up all the sides. We call anything that's rectangular perimeter, but when it comes to circles, there's another word for perimeter. When you think of a perimeter, if I'm thinking about the perimeter of this room, I'm thinking of this front wall plus the distance in front of the door plus the distance between where the flag is plus the distance along the yellow wall plus the distance around the green wall plus the distance around the orange wall plus the distance around this air conditioning out towards Jacob, then the distance from Jacob to Cassie, and then from Cassie to the yellow wall, and then the yellow wall to this corner, and so on. You add up all the sides. That's what perimeter is. Perimeter is when you add up all the sides. But when it comes to circles, there's another word for perimeter, and it's called circumference. Circumference is the perimeter of a circle. It's a fancy name for the perimeter of a circle. Now that we have that, what we're basically going to start doing is we're going to start doing some problems that come directly from your worksheet. So I have a couple that I picked out for you that we're going to do. Some of them are basic and some of them get a little bit harder, but let's start off with something that is medium intensity. This is like number 3. An 8-foot by 10-foot rug leaves 1 foot of space around a room. How big is... Oh, no, that's not what it said. It said find the perimeter of the room. Erase. Find the perimeter of the room. That's what we're supposed to do. Scoot this up a little. This must be either an older house or a house that has hardwood floors. Imagine that the floors in this particular house, there's this room, and what the people have is they have this hardwood floor, and sometimes they lay a rug on top of the hardwood floor with a nice little pattern on it, and there's a border around this rug that, and we can figure out how big is the room. So I want to draw you a quick picture for this. Here's the rug. And it doesn't matter which way is 8 and which one is 10, but it's an 8-foot by 10-foot rug, just like that. Okay? It's an 8-foot by 10-foot rug. And this particular room, it says it leaves 1 foot of space around a room. So there's 1 foot of space on this side. There's 1 foot of space on this side. There's 1 foot of space on the top. There's 1 foot of space on the bottom. So what I'm going to do is I'm going to kind of just color this rug a little bit like that, so I know that this is the rug. And then I'm going to draw this line that goes around this rug like that. And I know that this distance from here to here, from the rug to the wall, is 1 foot. On the right side, same thing on the top. From the top of the rug to the wall is 1 foot. And then from this side, it's 1 foot. And then from this side, it's 1 foot. So I just put a little 1 foot there as well. See how it works? The rug is 8 feet by 10 feet. And they're asking us to find the perimeter of this room. So this side here of this rectangular room isn't just 10 feet, it's 10 plus how much? Like, not just one, not just this side. We have to add this extra one on this side as well. So how far is that from here over to here? How far is that? 12 feet on this side. And what's this other side going to be? 10. Good. And that's still not the perimeter because we haven't added up all the sides. We only have this side and this side. What's this side going to be? 10. And the other side of the room? So if we're trying to find the perimeter, what we then have to do is we add up 10 plus 12 plus 10 plus 12. Or you can do 10 plus 12 and double it, times it by 2. I believe the perimeter is 44. And what are we measuring this in? I'm just curious. So, feet. Is it squared? Nope, it's just a distance. We're saying it's 44 feet around. Perimeter in real life is what we use to measure like how much baseboard you're going to put into your house. If I want to know, like see up here at the very bottom, this is called baseboard, this gray part where the wall meets the floor. It gives it a nice little trim. That's called a trim molding. If you've ever are going to remodel your house someday, or you're ever going to do something to a house, this is what you actually use it for in real life. I'm just curious. Miss Piccolo, have you ever had to deal with baseboard in your house?
Yes.
And so knowing the perimeter would help you on how much baseboard to purchase if you were going to do it yourself. Yes? Okay. So I've done it myself in my own house. Baseboard is really cheap to do yourself. It's $1 or so per square foot, or per linear foot. Sorry, not square foot. And so you could do it yourself for materials. And if it's way better than paying somebody else to do it, because they'll charge you like at least double. Okay. All right. That's number 3. That's perimeter. There you go. Next question. Find the circumference. Find the circumference. Let's go back. I got to go back. How do I find the circumference of a circle? There are 2 formulas that we can use. The first formula is 2 times pi times r. I'm going to put C equals 2 pi r. Or pi times d. Here are your 2 formulas. I'm going to get my highlighter out. For the circumference of a circle, I can either use 2 times pi times the radius, or I can use pi times the diameter. If you need to know what those letters stand for, C stands for circumference, R stands for radius, half of the circle, and D stands for the diameter. I'll draw you a quick little picture for that. This is what an R looks like from the center to the outside, whereas a D goes through the center and all the way to the other side. That's a diameter. So now when we get to question number 4, now they're going to ask us to find the circumference. Find circumference in terms of pi. That's going to be nice when they tell us we can do that. I really like it. Number 4 says, it looks like this. Find the circumference in terms of pi. And then it has a circle, and then it has a 16 from the middle to the outside. Let me zoom in just a little bit more. First question I have for you, is this 16 a radius or a diameter? Radius. Okay, so if you're going to make a choice between this formula on the left for circumference or the formula on the right, which one are you going to choose? I'm glad you said the one on the left. So let's go ahead and put circumference is equal to 2 times pi times our diameter. 2 times pi times r. More coffee. 2 pi. What's the radius? I heard somebody say 16. 2 times pi times 16. And this is what lets us do something. When it says circumference in terms of pi, they're telling you don't plug in 3.14159, all that stuff into that as the decimal. Leave your answer with a pi in the answer. Okay? That's what it means. Leave your answer with a pi in it. So I have 2 times pi times 16. I'm going to do the 2 times the 16. Do you know what 2 times 16 is? And then times pi, I'm just going to leave it like this, 32 pi. This is how we write our answer in terms of pi. As a matter of fact, this, I don't know if this is in inches or if it's in feet or if it's in meters. So a lot of times we just say 32 pi units, and that's our answer. It's not square units because circumference is like a perimeter. It's a distance outside, and we would just write 32 pi. Units is fine, or since it's blank there, you can leave it blank. It's fine with me. Okay, so you're going to have to find circumference. We're also going to have to find areas of rectangles and so on. So let's do an area problem as well, like number 9. Find the area. And number 9 says, find the area of the rectangle, and it says it has a base of 4 feet, and it says it has a height of 15 feet. It calls this the base, and it calls this the height. Find the area of the rectangle. 4 feet is the base, 15 is the height. The easiest way for you to find this, I don't even know if you need to draw a picture or not, but I'll draw a picture anyways, just for clarity's sake. We know that the bottom, the base, is 4 feet. We know that the height is 15 feet. Well, Mr. Paramo, that's not, doesn't match. Well, this is not to scale, okay? It doesn't match, it's fine. If I know that this is made up of 4 slices, 4 feet like this, and then there's 15, imagine that there's 15 of these little lines like that, and I want to know how many squares are in it, instead of counting each square individually, the fastest way to count is to just multiply your two numbers. If I want to know how many squares are in this, I take the 4 and I multiply it by the 15 to figure out what the area is. And so I'm going to write this up next to this problem just in case you need to see it. The area of a rectangle is our base times our height. It's the fastest way to count all the squares that will fit inside a particular rectangle. I'm going to get my highlighter. I'm going to highlight this one because I use this one often. Every formula that we have in this unit is going to be based off of this one right here. I will eventually show you all how we get the triangle formula from this, how we get the parallelogram formula from this, how we get the trapezoid formula from this. And the way this works is, if I have 4 on this side and 15 on this side, instead of counting how many boxes, how many squares fit, what we can do simply is multiply one side to the other, and it will count how many that we have total. So how do I find the area of this rectangle? I just do 4 times 15. And it's feet times feet. I hope you see that. That's one of the reasons why our answer should be feet squared, because we have 4 feet times 15 feet. Feet times feet is feet squared. 4 times 15, I believe, is 60. Does that sound right? And so the answer to number 9 is 60 feet squared. Do
you need to put A equals, or can you just leave it?
You can put the answer. This is a perfect answer right there. 60 feet squared. The area is equal to 60 feet squared. I only put the A there because I believe when we get to your chapter test or your quiz, it's going to say find the perimeter over here and find your area over here. So you kind of know what you're solving for. Okay, what about area of a circle? Area of a circle in terms of pi. Okay, let's do that one here, then I'll turn this page over. Area of the circle in terms of pi. Let's write down what the formula is. Do you know? You should have seen it some other time in your life. What's the formula for the area of a circle? We don't know.
C equals 2.
Nope, that's circumference. Pi r squared. Pi r squared. Area of a circle is pi times the radius squared. So I'm going to put a highlighter around that one as well. Let's go ahead and do number 13. Number 13 has a picture that looks like this, and it's going to try to trick you. Right here has a 200. It says find the area of the circle in terms of pi. And it does say 200 here, and this has a bar that goes all the way across the circle. So my very first question to you is this a radius? So they are trying to trick you on number 13. They gave you a diameter. What is the radius? Okay, so I'm going to put r equals 100 just so I know. They didn't give that to you, but that's what it is. And then what we have to do is find the area. Now I'm going to plug it into like this formula. Pi times 100 is the radius squared. And I get to leave my answer in terms of pi. If you don't know what 100 squared is, there is a square button on your calculators. The square button is right there where it says x squared. When you press it, it gives you that little second power right there. 100 squared. How many zeros will it be? If you said 4 zeros, you are correct. And so I get to say, and I just want to show you that just in case you wanted to put in the pi as well, let's do 100 squared times shift pi. What I like about these particular calculators is they will actually put it in terms of pi for you. If you want to put the pi in there, it will do it in terms of pi. It's kind of neat. And then if you want to plug in 3.14, then you can press the button and it will give you what is 10,000 pi times 3.14, 159,265, whatever it is. I think it's 535. Okay. Over. Turn this over. The last example that I want to do with you before I pass out your packet is an example like number 16. This is as complicated as it gets. It has a picture like this. Find the area. And number 16 looks like this. It has a spot here that's 4. It has a spot here that is 2. It has a thing that goes up, goes to the right, goes down, and this down is a 2, and this right is a 2, and then it goes up, and the top is 7. Seven, 4, 2, 2, 2. But not everything is labeled. Just like that. That's exactly how it looks to start. This is way more realistic and what real life is like. I hate when math problems don't make things realistic, and this is exactly how life is. Remember how I was talking to you about how me and Miss Piccolo, we've done baseboard or molding and stuff like that in our houses. When you buy molding, you have to account for this wall and what goes around that door and what goes around the AC. You have to go in and out of things. Rooms are very rarely perfect rectangles. When I look, if I was to do base molding here, we don't have a perfect rectangular room because we have the door that kind of comes out this way and it goes in towards the flag. It goes around this thing. I have this little corner that takes out that perfect corner from there, and then I have that AC that juts out. The rooms are never perfect rectangles, hardly ever. Okay, this is what a room looks like. You can imagine that there's like an AC unit right here, and you have to go and figure out how much baseboard is going to go around, including the AC unit. That's how life works. So if we know that this is 7, this is 4, this is 2, this is 2, what we can start doing is we can start chopping this up into little rectangles and adding those rectangles areas together. If I need to find the area, then you can do a couple things. You can find the area of the whole thing and subtract the missing area. That's probably what I would do. If I were you, if I want to find the area of this whole thing, and let me just draw a little dotted line right there. And I'm going to color this spot in with red and the other one with blue. Can you tell that that's red?
Yes.
Okay, let me go with the checkered then. Checkered. That checkered spot right there is red. What I'm going to do is I'm going to find the area of this entire, like I'm going to pretend this was a rectangle that was filled in. I'm going to find that whole area, then I'm going to subtract the red area. Then I can find out what the area is. I think that's the easiest way to do it. So I'm going to do the blue area minus the red area. Okay. So the blue area. I want the length and the width of the blue area, something that's the full distance across times the full height. What do you think? What are the two numbers that you're going to use?
7 and 4.
If you said 7 and 4, I agree with you. That will figure out in the entire area, including the red part. And then we're going to subtract the red area. Now the red area is a little bit harder because I only have the height. I only know that from here to here it's 2. What I don't know is how long it is, unless I do some other form of logic. Do you know how long this is?
3.
How do you know that it's 3?
Because we subtract 2 G's.
Right. How far was this side?
7.
So if this is 2 and this is 2, then we can think of a little line, dotted line going up and another dotted line going up, and that this is 2 and that's 2 and that needs to equal 7. So that missing spot has to be a distance of 3. So the red area is 3 by 2. So if I want to know what the area of this other thing is, I'm going to do 7 times 4 minus 3 times 2. And order of operations. You can plug this whole thing in your calculator, or you can just do it by pieces. 7 times 4 is 28. Minus 3 times 2 is 6. Which means it is. And it doesn't say what it's measured in, so I'm just going to write units squared because this is area for number 16. There are some other problems that are on here that you might have to work backwards, but I feel like what I've done is enough for you to get through. We'll stop right there with your notes.